Amy Beise is the team leader for research and pavement design within the Materials and Research Division. She oversees the operations of the research program, concrete bituminous thickness recommendations, falling weight deflectometer, data collection, and pavement profiling. Amy currently is organizing the initiatives of the Hot Mix Asphalt Advancement Group. Justin Ramsey will present the second part of the presentation. Justin has been working for the department since receiving his construction engineering degree from NDSU in 2003. He spent over 4 years in the construction pool, followed by 5 years in technical support in the design division. Since 2011, he's been the team leader in the transportation services section of the Environmental and Transportation Services Division, overseeing specifications, special provisions, value engineering, and various other unique tasks. So with that, I'll turn it over to Amy.
Thank you, Matt. So yes, welcome everybody. Justin and I are really excited to be here today and share some of the things we're looking at internally and externally in the asphalt materials world. So I would like to start out this presentation with just drawing some attention to how big our asphalt paving program actually is. So when we looked back through bid reports in 2020, the DOT invested over $99 million in hot mix asphalt. That's a lot of money. That's a decent piece of the pie when you look at our overall construction budget going to just one material. So when it comes to the actual amount of money going into asphalt pavements, I really want to talk about it in terms of investment and not spending. We invest this money in pavement, we want it to last, we want it to serve the traveling public for as long as possible, really. And you know, when you talk about asphalt as an investment, it really shifts the mindset a little bit from asphalt being this consumable material to how do we protect this investment? How do we really get a return on this investment? So one of the key things to protecting that investment in asphalt is its density. Asphalt density, it's a measure of quality, and overall it really is a predictor of longevity. If you want quality and longevity in the end, it really does have to start in the beginning, talking plan development, project development. You need to spec it into the project, design it into the mix design, and then you achieve it in the field through your roller compaction. A good rule of thumb when it comes to asphalt density is that for every 1% increase in field density, it results in about 10% increase in service life, and vice versa. And this is really true around the 93% density mark. So that's your return on investment. There's definitely some gains to come from increasing the density, even by just 1%. You can have the best materials, you know, you can have the best mix design. If you go out there and you build it with substandard density, it's going to fail prematurely. It's not going to last as long as we want. So I guess if we apply like numbers to this concept, say we want a pavement to last 20 years. That plus or minus 1%, that can make the difference between an 18-year service life pavement to a 22-year service life pavement. You project this on our entire state network over an entire asphalt paving program, it really compounds itself and adds up quickly. So before I talk about how we actually can improve asphalt density, I actually want to just go back a step and talk about what it is and how we measure it. I like to teach, so we're going to go to asphalt density school here for just a minute and talk about what it is. So basically, asphalt mixtures, there's really only 3 components to them. You have your aggregates, you have your asphalt binder, which is the glue that holds all your aggregates together, and then you've got some amount of air or air voids. And the core to asphalt mixes really is in volumetrics. Everything has weight, it takes up volume, and the relationships between these control the makeup of our asphalt mixtures. So density really, it's just a unit weight of a material, weight divided by volume. The more weight you can cram into a tinier space, the denser something becomes. So if you take that concept one step further, there's the concept of specific gravities, which is just the density of some type of material, the relationship of that material to the density of water. So the relationship of some type of density to the density of water, which is a constant. And in asphalt mixtures, there's all kinds of specific gravities. You have specific gravities of your mixtures, specific gravities of your stone, which are your aggregates. And then you have specific gravities of your binders. And all these specific gravities really control the overall makeup of the mix. It's how we determine the end air void structure, which is really important to the stability of mixtures. So I talked about density as being a unit weight. That really is what it is, but that's not how we measure it. So if you go to our current spec book and actually look for how density is measured, you're going to find this percent density. And what that actually is a measure of, it's the bulk specific gravity of your field core to the bulk or the theoretical maximum specific gravity of your mixture. So it's the percentage of what you're actually getting in the field to what the theoretical maximum that mixture can provide. That's your percent density. Now your air voids are what's left. So it's 100 minus your percent density. That's your air voids. Just a couple examples here. Say we say something's compacted to 92% density. What we really mean is that there's 8% air voids in that mix. That adds up to 100. If we say there's 95% density, that really means there's 5% air voids in that mix. So pretty simple concept. Now, reducing air voids and increasing density, it definitely has some benefits. Overall, you have a more stable pavement structure. As asphalt binders are exposed to air, they oxidize and they age. And by having lower air voids, it really seals out the internal part of the mix and it slows down that oxidation process. It can reduce cracking and rutting. It also keeps water out of the pavements, which is really important. Asphalt pavements hate water. Water gets in our pavements, it strips the binder away from the aggregates, it causes raveling, stripping. So we figure if we are investing this much money into asphalt, it really is worth taking a serious look at what we do, why we do it, and really asking ourselves, is there any room for improvement? And so this is where we pulled an internal working group together at the DOT. We call ourselves the Hot Mix Asphalt Advancement Groups. And we're literally looking for some ways that we can improve density and just to overall improve the quality of what we have, take it a little bit further. And so some of the things we're looking at are specification changes. I'm going to elaborate more on a percent within limit specification change. We can look at improving our quality control through rolling and paving operations. We have spec'd out intelligent compaction and paver mounted thermal profiling on several jobs the past few years, and we're going to continue to do that in the future. You can also increase your lift thicknesses. Now this is something, it's a recent change to the spec book, but it is in the current spec book. Now you can pave up to a 3-inch lift. Thicker lifts are easier to compact. They hold the heat in the mat longer. They allow for a longer window of time for compaction and just overall allow for the particles to move around and densify themselves. And then lastly, we can look at modifying the mix design. One thing we're looking at is what's called a super paved 5. So this concept is where you design a mix to 5% air voids, and then you actually target that same 5% air voids in the field. But what I want to elaborate on is the percent within limits. So what this is, it's a statistical acceptance of density. And really the goal is to reduce variability. So we first heard about this concept by talking with our local FHWA division office, and then also doing a peer exchange with the South Dakota DOT. South Dakota uses this type of acceptance as standard practice for all of their asphalt densities. And what this percent within limit specification does, it doesn't actually change the material, but it changes the way you accept the material. And I will elaborate on that right now. So if you have a large data set, the distribution of all the values in that data set, it looks like a bell curve, or what's called a normal distribution curve. So the peak of this curve, or the highest point of the curve, that's your average of all your values. And then the standard deviation is the width of your curve, or how wide it is, that represents your variability. And all the area underneath the curve, that sums up to 100%. So the entire population that you have. So some things to note about normal distribution curves: because the area underneath the curve, that sums up to 100%. As your variability gets lower and your standard deviations get lower, these curves get skinnier and taller. And as your standard deviations get higher, or there's more variability, these curves get wider and shorter. So how does that actually relate to paving, you're probably wondering. So if we were to pave a new project, we would consider the density of that mat a large data set that's normally distributed. So with our current way of accepting density, we specify an average. So as long as the percent average density of core values of that lot is met, full payment can be laid. You just have to average out to whatever that specified average is to be okay. But the reality is that this can happen. You can have half of your values come in below that specified average and half come in above. Well, that's not really what we want. This area in red is kind of what I'd like to call room for improvement. We can definitely do better here. This area in red, what it is undetected variability, and it does impact the long-term pavement performance. So here's how percent within limits comes into play and compares. So instead of saying a specified average, we're going to go ahead and cross that out. We don't like it. And now we're going to call that the lower spec limit, because that's actually what we want. We really don't want densities running below 92%. Then we're going to spec out an upper spec limit. And what the percent within limit specification does is it tells you the percentage of the total population that you want falling between these two targets, your upper spec limit and your lower spec limit. That's where the percent within limits name comes from. So what really happens is, to achieve this and not get a penalty, the entire population has to shift up. The curve has to get taller and skinnier. There needs to be less variability to fit most of the area between these two lines. So we're going to see less of these areas in red that we don't want, and we're going to see a lot more areas in green, because this is the range that we actually do want. So this is where I want to point out that you could be thinking to yourself, why don't you just increase the average spec limit, just bump it a percent? Well, that doesn't actually control your variability. It's kind of like an old saying that you're only really as good as your weakest link. And that's really true for asphalt densities too. You're really only as good as your lowest cores. You're only really as good as your lowest areas of density. When it comes into looking to the future, you know, this area in red down here, that's really going to determine your future maintenance strategies, how quick those are going to come about, and how much maintenance and rehabilitation you're going to have to do and how quick it's going to come. So we have tested out 2 of these percent within limit projects in the 2020 paving season. First up, we had the Valley City District project on Highway 46. This was 52,000 tons of super pave FAA 43 wrap mix. Second project we did was in the Grand Forks District on Highway 1, and that was 38,500 tons of that same FAA 43 wrap mix. Now, Knife River was awarded both of these projects. They did the Valley City District project first in late summer. Then they went up to Grand Forks and constructed that project in early fall. So here's how they did. This was the Valley City District project. This represents the entire project. So the entire paving project, not like a lot or anything like that. So they had 93.7% average density. They had a standard deviation of 1.5, and the percent within limits, the percent under the curve falling in that white area, was 85%. The area in the gray boxes, that's really what we don't want. So that was the remaining 15%. That's not too bad. So then they went up to the Grand Forks District. And really you can tell that the contractor learned some tricks. The average density was about the same. You see the peaks of the curves are about in the same spot. But what you notice with this red curve, the one that represents the Grand Forks District project, is the standard deviation was lower. So those areas under the curve in the gray, are also lower, and the percent within limit that we want is higher, or 91%. So that was really good. Hats off to Knife River for a couple of really good projects. And then just for fun, we wanted to say, how do these percent within limits compare to our typical FAA 43 super paid mixes? So we put all of the historical FAA 43 projects from the past several years together. And what that looks like is, on average, it's about a 92.7% density, 1.5% standard deviation, but only 66% within limits. Now, yes, the specifications were different, the targets were different, but what you really notice is the peaks of those curves are about 1% apart. And at the beginning of this presentation, I told you what that percent really means. That's 10% service life. So these percent within limits, they definitely showed an improvement on the same mix, that it is definitely possible. Now, some observations we had. One observation we had is that there was very few cores that fell below the 92%. This type of specification, it had both incentives and disincentives, and so it was very sensitive to that. If you were getting cores below 92%, it was very sensitive to what you were getting paid, because that core below it actually represented the probability of the entire mat being below. We also noticed that the contractor upped their quality control. They had individuals with nuke gauges behind the paver, constantly monitoring the quality, being proactive, not reactive, really waiting for confirmation of those cores. And overall, I think it did discourage disincentive paving. There was a little bit of disincentive days, but it was corrected very quickly. And I just want to end that quality really is everybody's role. It's everybody's job. And it's really important to know your role in quality, take ownership of it, because all working together, it does make a difference in the quality of the pavements and how long they last for our traveling public. So with that, I'm actually going to pass it off to Justin Ramsey, and he's going to talk about how he took this internal group we had going, and he really took it to the next level and partnered us up with the AGC by creating the AGC Hot Mix Asphalt User Producer Group. So take it away, Justin.
Thank you, Amy. Grab my presentation here quickly. There we go. Okay, as Amy mentioned, we had the internal group, and as we're looking at these changes, we wanted to obviously make sure we had industry involved. So we talked with the AGC and we set up the user producer group. The purpose is pretty obvious, but we wrote it down on here anyway, and it's just to create that information flow, the idea flow back and forth between everybody. Everyone in that group has great ideas, has great insight into how we can improve things. We see different things that as a state agency than the contractors see. There's different focuses there. Obviously, some of our contractors work in other states, so they can bring things back to us in that regard. We first started up that group about 1.5 years ago. We met a couple of times, and then the world kind of went crazy on us for a while. So our meetings slowed down there a little bit, as you can see on the slide here. Our goal is to meet more regularly. We're hoping for a bi-monthly schedule, which is how our internal group meets too. We've been doubling up on those meetings. We'll meet with one group in the morning and the other in the afternoon. So it sort of helps us on the DOT side to keep those thoughts from one meeting to the next and make sure we're moving forward on some of that stuff without getting too far away from those ideas, without being able to do anything with them. I've been trying to remember what we were doing. Our next meeting for both of those groups is kind of penciled in for the end of May. So Amy talked about density predominantly here, but she also mentioned there's a lot of other things. So I wanted to touch on some of the stuff that that group has talked about. We've talked about joint density. That's obviously been in play for all last summer for all projects. It's out there again this year with some tweaks based on discussions that these groups have had. The coring locations, that's something that's come up quite a bit. Overall, we're looking at hopefully trying to find a way to reduce the number of cores that we take. Obviously, when we introduced that joint coring, We effectively doubled the number of cores that we took the first year. We backed that off a little bit by changing that SP, so we're taking half as many cores in the joint now as we did last year, so that'll be good. Mat density incentives, I'll touch on that a little bit later, but those were introduced partly through this group, or these two groups. The PWL that Amy talked about, obviously. Aggregate specific gravity is a big topic that we've touched on numerous times. Amy mentioned that that's part of the whole package of how the density gets calculated. So knowing how that works and what affects it is a big key to getting that mix design put together properly. We've talked about narrowing down the number of grades of binders and FAA that we have, just because we typically tend to skew towards a couple of things. It might make our mix design process and our specification process a little bit easier if we narrowed up what we're asking for. Evaluating what our wrap looks like as it goes into the mix, and determining what kind of material we're actually providing from the existing roadway when we put it in for recycle. We're doing more and more of those every year, it seems like, so getting a better handle on that seems like something that could provide a benefit. And Amy mentioned the mix design, the gyrations, that changes the maximum theoretical density. So if we modify that, we make it a little bit of more oil in our mix. That provides us with a different kind of density in the field that, there's trade-offs there as far as longevity goes, and that's something we're just evaluating. And then we're also looking at the worksheets in the workbook that are used to calculate and track all of this information in the field. I'll get back to that one a little bit later here too. We also talked about the current special provisions that are out there. The 3 that are listed on the screen are in all of our projects this year. The biggest kind of pieces to these that changed maybe from last year to this year, and why these even exist. Obviously, the joint density one is something that we're still doing by SP because it's a new concept. We want to be able to work on that as we go. Again, I mentioned this a little bit ago, but we changed up the coring on those. That's kind of the biggest change from last year. There's also a diagram in there showing the notched wedge joint, which was something that was a little bit popular last year, and we saw good results with, so that we just put a drawing in there so everybody kind of knew what that looked like in the field if they weren't familiar with it. The bitumen testing price adjustments, SSP 7, this replaces a document that was only found on the DOT website prior to this, and had to do with how, when oil is tested, if it falls below some of the AASHTO thresholds, how it was paid for. We took that off the internet, updated it for the MSCR oils that we're using, those polymer modified oils, and got that directly into the contract document, so it's a little easier to find. It doesn't come into play very often, but we just wanted it to be a little bit more obvious where that was. And then SSP 9 has to do with the HMA coring, the mat coring, and the biggest thing there was we went through some discussions on how we wanted to do shoulders and things like that. And this SP got put out to clarify some stuff that was in the 2020 specifications, didn't quite line up with how we ultimately decided we wanted to do things. So we have all these meetings, we've met a bunch of times, but what actually are we doing? Are we just talking to each other, or are we actually seeing some results? So I put this together to show that we actually are, there's things that are coming out of these discussions that we're using. The density incentives, those are in the standard specs. So that's really kind of probably the most prominent one, I guess I'll say, other than the joint to SP, which is the second bullet on there. So these discussions have been productive. The coring reductions were obtained. Were discussed as part of this too. And again, like we said, we're still looking at trying to do that. We obviously reduced them by changing the joint density coring. And then some improvements to the PWL concept that were a direct result of the discussions that we had with these groups. What is coming up? We are going to do some additional PWL projects in 2022. I believe we're looking for a handful of jobs throughout the state, seeking in different districts. The Valley City and Grand Forks, those projects obviously went pretty well. We want to try and expand that to some of our other districts so that there's some more familiarity with that concept in our other areas. Super Pave 5, we're going to start developing an SP for that, as Amy mentioned, based on some other states. Improving that workbook that's out there. The ease of the use and the coverage for these pilot projects. Lauren Lee in the Bismarck district has been huge in getting that thing put together for us and taking these unique jobs that we're doing, whether it's a PWL or a little bit of a different density table that we've done on projects, and modifying that workbook to work for those projects. He's been fantastic on that, and thank you very much, Lauren. And then the density profiling system, materials and research is going to be collecting data on this coming summer. That's a really neat deal. And if anybody was at the HMA conference the last couple of days that LTAP put on, or the asphalt conference, I should say, there was some discussion of that from Bryce Worry. I think he's got one too. So that's kind of a neat program that we could maybe hopefully do less coring in the future. The PWL, I wanted to touch on this again and show how this group really has had a real impact on how we're doing stuff. So as Amy mentioned, Knife River Paving ran both those jobs. And because they were part of this group, the HMA user producer group, along with representatives from both of the Grand Forks and Valley City districts, they were able to work through a change in the field after the bid to revise the way that we were looking at lots and make them work a little bit better for how the paving was going to function. So I'm not going to run through the technical aspects of this, but I just wanted to say that because of those interactions, everyone that was involved in those projects knew what the expectations were, and they were able to go through and make some updates to that were a real benefit to the SP. And when we do this again, it's going to look more like what they did in the field on those two jobs and what we put out there originally. So there's a lot of good aspects of having these discussions between the two groups, the DOT and the contractors. So Amy touched on how the percent within limits looks on a graph. I wanted to throw this up there just to show how we got that graph. This is a straight steal from South Dakota. As she mentioned, they do this for every project. So rather than reinventing the wheel, we just took their math and plugged it into our special provision. It looks daunting, but as I said, Lauren has put together the spreadsheet so that it just does this for us, which is fantastic. I did go through this and do it by hand with some dummy numbers, and it took a little while. It wasn't super complicated, but it wasn't the quickest thing in the world either, especially when you're trying to teach it to yourself. So having that kind of automated is fantastic. But these are directly out of those special provisions, and this gets us those curves. And as Amy mentioned, trying to get better density, PWL is just one way to do that. It's more consistent for sure, but we also just want to kind of bring up our density overall. So as part of that, we implemented MAD density incentives on the 2020 spec book. So anything that's being bid under that and going forward is going to have these extra lines in here that I've highlighted. Everything below that is what we've had historically for the last 8 or 10 years. But we added these extra lines above because we want to see some higher numbers, and we're willing to compensate contractors for the effort that goes into that. Part of Amy's chart had the historical average on there for FAA 43, and as we've been analyzing as an agency some of the numbers that we've gotten in the past, what we noticed was, by and large, looking at all the cores that we've gotten together and the pay factors that we've put out, we're shooting and landing around that 0.98% pay factor, which is a little bit lower density than we want to, obviously, but it just sort of goes to show that, we're not hitting that 100%, which you're not good on an average basis anyway. But if we can bring that up by showing the contractors like, hey, if you shoot for a 1.03 and you hit a 1.0, we're happy with that. You're happy with that because there's not a disincentive going into that. And we get that extra life out of it, whether that's, a full percentage or even just a 0.5% and getting some of that extra value back. So that's just one way we're looking at trying to get some better densities out there. There's a lot of people involved with these groups. The DOT team is there. Carrie Burke, Ted Bilodeau from the AGC are kind of our primary members, the point of contact at the AGC for this. Danny Schmidt was a huge help after Knife River got those two projects on talking through things, especially with that change that we made to the lots. Gary Goff at FHWA and obviously Ken Sudin at DAPA are huge parts of this too, and helping us get a grasp on what we're doing, what we're looking at, and what our expectations should be for everybody. So big thank you to all the folks that are listed here, as well as anybody else that's worked with us on these and the various aspects of stuff too. And with that, Amy and I's contact information is here. If you have any questions after this, please get a hold of us. But if we're going to take questions now, we can certainly do that.
Yeah. Thank you, Justin. Thank you, Amy. Great job. Great presentation talking about protecting our investments for the future. So there's some questions that come into the chat box, and we'll run through a couple of these. First question is, how was contractor feedback on these projects that had PWL?
So I can answer that, Matt. So there was only one contractor. Knife River got both of them, same paving crew. You know, the feedback we got, this is a tough spec to meet. It is a drastic change from where we were at to where we are with this spec. The previous spec only requires a lot average of 91%, and now we're saying we want a majority of all of your population to be between 92 and 97. So they definitely acknowledged that it is a tough spec to meet, but their numbers prove they did it. So the thing that I think we got the most feedback on is just the importance of getting the cores back to the contractor, because there is money on the line. And if they're doing things wrong, they want to adjust that stuff quick. And so that's really why we probably saw them following the pavers with extra quality control with the nuke gauges, just monitoring their quality for themselves so that they're not relying on those cores to come back. But overall, they were not objecting to doing future projects in the future when we debriefed with them.
Yeah, thanks, Amy. I think Justin or you touched on this, but the next question is, are there plans for more PWL projects in the future?
Yes, we are looking at doing a few more. We met with our management after the debrief with the contractors, got that feedback, and said we'd like to do a few more of these, get some more experience out there, get some for both us and hopefully some additional contractors. Now that we've seen, you know, how things can go, so we are looking for some jobs for 2022 construction. So if there's some districts on the line that have some some spots that they want to try this out on, reach out to Matt, myself, and Amy, and we'll see what we can do.
Okay, we got the one more question, which is actually a two-part question, is how does the life cycle cost of implementing PWL spec compare with the previous specification? And how much more effort or resources does it require of the contractor to achieve the densities of the PWL spec?
You know, I think the answer to both of those questions really is time will tell. We've only got 2 pilot projects under our belt. We didn't see anything crazy with the bid items. We do expect that it's probably going to be a little bit more expensive because it is going to take more effort. But we also put an incentive on the line, and we also expect to see those get wrapped back into the competitive bidding process. If they think they can achieve an incentive, theoretically, they should be able to lower their bid prices. But, you know, I don't know if we have a specific answer to that question yet, but it is something we are going to be tracking those things as we do these, because we do want to make sure if we're putting effort into things that there is a return on investment to that effort. But overall, we were very satisfied and confident that these ones definitely paid out to the DOT.
And that's something to chime in the end there, Amy, on even on the standard density incentive that we're putting in place. We're going to keep an eye on that to make sure that we're getting a good return on that investment as well. You know, do our densities come up versus what we're putting out there as the incentives, and what impact that might have on our bid items. So we're going to be keeping an eye on that as well.